Stop scrolling right now because what happened to Winter Storm Ezra over a 12-hour period from Sunday evening, December 29th, into Monday morning is rewriting everything meteorologists thought they knew about rapid storm intensification. At 8 a.m. Sunday morning, this system was a routine winter low-pressure area tracking across the Great Plains. By 8 p.m. that same night, it had exploded into a full-blown bomb cyclone with atmospheric pressure dropping so fast that 30 million additional Americans were placed under emergency wind alerts in just 9 hours. At the 4-minute mark, I'll reveal the exact atmospheric mechanism that triggered this explosive transformation. By minute 8, you'll understand why 27,000 people lost power and over 9,800 flights were disrupted before most Americans even realized a catastrophic storm was developing. And at minute 12, I'll show you the 3 warning signs meteorologists now know predict when a normal winter storm is about to undergo bombogenesis, signs that could save your life during the next rapid intensification event. Here's a number that should immediately grab your attention. Between Sunday morning, December 29th, 2025 at 7 a.m. and Monday afternoon, December 30th at 1 p.m., atmospheric pressure at the storm center plummeted from approximately 1,003 millibars to 979 millibars. That's a drop of 24 millibars in less than 30 hours. To put that in perspective, a typical winter storm might drop 8 to 12 millibars over 48 hours. This storm dropped double that amount in half the time. When meteorologists see pressure falling this rapidly, they use a term that sounds like it belongs in a military briefing: bombogenesis. It's the atmospheric equivalent of a controlled explosion, except there's nothing controlled about it. Let me be absolutely clear about what makes this particular storm genuinely catastrophic and unprecedented in the modern forecasting era. It's not that bomb cyclones are rare. We see several every winter across the North Atlantic and North Pacific. What made Winter Storm Ezra extraordinary was the combination of location, timing, and the sheer number of people caught in its path during the peak holiday travel period. On Sunday morning, December 29th, 20 million Americans were under wind alerts as forecasters tracked what appeared to be a strong but manageable winter system. By Sunday afternoon at 5 p.m., that number had exploded to over 50 million people. Think about that for a moment. In 9 hours, the number of Americans facing dangerous conditions more than doubled, not because the storm changed direction, but because it intensified so rapidly that its danger zone expanded by hundreds of miles in every direction. Here's the timeline of transformation that demonstrates how quickly atmospheric conditions can deteriorate from routine to catastrophic. Sunday morning, December 29th, 8 a.m. Central Time. Weather models show a developing low-pressure system over the southern plains, pulling warm, moist air northward from the Gulf of Mexico, while Arctic air gradually spreads southward from Canada. Forecasters issue winter storm watches for the upper Midwest and Great Lakes, standard procedure for this type of setup. The storm's central pressure reads approximately 1,003 millibars. Wind speeds near the center are 25 to 35 miles per hour. Travel advisories are posted, but conditions remain manageable across most of the impact zone. Sunday afternoon, December 29th, 2 p.m. Central Time, the storm begins its northeastward track from the southern plains toward the Great Lakes. Meteorologists notice something unusual in the latest model runs. The pressure gradient is tightening faster than earlier forecasts predicted, meaning isobars, those lines on weather maps that connect points of equal atmospheric pressure, are getting closer together. When isobars squeeze tight, wind speeds increase dramatically. What looked like 35-mile-per-hour winds in morning forecasts are now projected to reach 50 to 60 miles per hour by evening. Emergency managers in Michigan, Wisconsin, and Minnesota start activating winter storm protocols earlier than originally planned. Sunday evening, December 29th, 6 p.m. Central Time. This is when everything changes. The National Weather Service begins issuing blizzard warnings for portions of the upper Midwest as surface observations confirm what models had been hinting at all day. The storm is undergoing rapid intensification. Atmospheric pressure at the center has dropped to 991 millibars, a 12 millibar drop in just 10 hours. Wind gusts are now being clocked at 55 to 65 miles per hour across portions of Minnesota and Wisconsin. Snow is falling at rates of 2 to 3 inches per hour in some locations. Visibility drops to near zero in blowing snow. Interstate highways become parking lots as travelers who left home that morning, assuming normal winter conditions, find themselves in whiteout emergencies. Sunday night, December 29th, 10 p.m. Central Time, the transformation is complete. Winter storm. Ezra is now officially classified as a bomb cyclone, having met the meteorological definition of bombogenesis with a pressure drop exceeding 24 millibars in 24 hours. The storm's central pressure reads 983 millibars and is still falling. Wind alerts now extend from Texas through Pennsylvania and New Jersey, affecting over 50 million Americans. Power companies report the first major outages as 60-mile-per-hour wind gusts snap power lines weighted down by ice and wet snow. Michigan bears the brunt with over 10,000 customers in the dark, a number that will more than double by morning. Monday morning, December 30th, 8th a.m. Eastern Time. 12 hours after the rapid intensification began, Winter Storm Ezra reaches its peak fury. The bomb cyclone's central pressure bottoms out at 979 millibars over the northeast United States and eastern Canada. At this point, the storm has generated winds equivalent to a Category 1 hurricane. The isobars on weather maps are so tightly packed they look like fingerprints, each line representing a massive pressure gradient driving severe winds. Over 27,000 customers are without power, with Michigan accounting for more than one-third of all outages. Air travel infrastructure collapses under the assault. By the time the storm begins weakening Monday afternoon, 9,000 flights have been delayed and 889 completely canceled. Passengers stranded in airports from Chicago to Boston face the reality that rapid storm intensification doesn't just affect people at home, it shuts down the entire transportation network for hundreds of millions. Now let me explain the atmospheric physics that transforms a routine winter storm into a catastrophic bomb cyclone in just 12 hours, because understanding the mechanism is critical to recognizing the warning signs. Bomb cyclones form through a process meteorologists call explosive cyclogenesis or bombogenesis. It requires 3 specific atmospheric ingredients to come together in precise timing and location. First, you need a sharp temperature contrast between 2 air masses. In Winter Storm Ezra's case, that contrast came from Arctic air plunging southward from Canada, colliding with warm, moist Gulf air being pulled northward. The temperature difference between these air masses exceeded 60 degrees Fahrenheit over a distance of just a few hundred miles. Second, you need the collision to occur over or near a warm ocean current or large body of relatively warm water. The Great Lakes provided this ingredient. Even in late December, water temperatures in the Great Lakes ranged from 38 to 42 degrees Fahrenheit, significantly warmer than the Arctic air mass moving over them. This temperature difference creates a heat engine that adds tremendous energy to the developing storm system. Warm water evaporates into the cold air, releasing latent heat as the moisture condenses into clouds and precipitation. This latent heat release is like adding fuel to a fire. It causes air to rise rapidly, which lowers surface pressure, which pulls more air inward toward the storm center, which creates stronger winds, which pulls more moisture from the lakes, releasing more latent heat, creating a self-reinforcing feedback loop. Third, you need favorable upper-level atmospheric dynamics, specifically a jet stream configuration that enhances divergence aloft. In simpler terms, air needs to be evacuated from the top of the storm system faster than it flows in at the surface. During Winter Storm Ezra's rapid intensification phase, the polar jet stream was positioned perfectly to create this upper-level divergence. Think of it like opening a chimney flue. When you open the damper on a fireplace, smoke and heat rush upward more rapidly, which draws more air in through the bottom, which makes the fire burn hotter. The jet stream performed this exact function for Winter Storm Ezra, sucking air upward from the storm's center, causing surface pressure to plummet, which drew surrounding air inward with increasing violence. What makes this process catastrophic rather than merely dangerous is the speed. Typical winter storms develop over 36 to 48 hours, giving forecasters time to issue warnings. emergency managers time to position resources, and the public time to prepare. Bomb cyclones compress this timeline into 12 to 24 hours. The storm that looked manageable Sunday morning had become a life-threatening emergency by Sunday evening. People who began driving Sunday afternoon expecting routine winter weather found themselves trapped in blizzard conditions by dinner time. Emergency responders who thought they'd have Monday morning to prepare were dealing with full-scale crisis response by Sunday night. For those of you over 30, you remember when winter storms developed more predictably, when forecasters could give you 48 to 72 hours notice before major events, when you had time to stock up on supplies and adjust your schedule. That world is disappearing. Climate change is altering atmospheric patterns in ways that increase the frequency and intensity of rapid intensification events. Arctic amplification, the phenomenon where the Arctic warms faster than mid-latitudes, is reducing the temperature gradient that normally keeps the jet stream stable. A wavier, more unstable jet stream creates conditions where air masses with extreme temperature differences can collide more suddenly and more violently. Here's what the data tells us about the changing frequency of these explosive storms. Research analyzing Northern Hemisphere cyclone behavior shows that bombogenesis events, while always present in the historical record, are occurring in different locations and with different characteristics than past decades. The Atlantic Gulf Stream and Kuroshio Current in the Western Pacific remain the primary breeding grounds for bomb cyclones, with an average of 45 explosive cyclogenesis events per year in the Northern Hemisphere. But the distribution is shifting. Storms that once reliably tracked well offshore are now developing closer to populated coastlines. Systems that historically intensified over open ocean are now undergoing bombogenesis over or near land, putting tens of millions of people in direct danger. Now let me reveal the 3 warning signs that meteorologists now know predict when a normal winter storm is about to undergo catastrophic, rapid intensification. Warning sign number 1, rapidly tightening pressure gradients in 12-hour model forecasts. When successive forecast runs show isobars packing closer together on weather maps, that's the atmosphere's way of signaling explosive development is imminent. During Winter Storm Ezra, meteorologists noticed this pattern emerging in Sunday morning data. Models that at 6 a.m. showed moderate pressure falls were showing accelerated pressure drops by noon. When you see forecast discussions from the National Weather Service using phrases like rapidly intensifying or pressure falls accelerating, that's code for potential bombogenesis. Warning sign number 2, abnormally warm lake or ocean surface temperatures relative to the season combined with Arctic air mass intrusion. The mechanism I described earlier, where cold air over warm water creates explosive latent heat release, only works when the temperature contrast is extreme. During late December 2025, Great Lakes water temperatures were running 3 to 5 degrees above normal for the date due to the unusually mild fall. When Arctic air with temperatures 20 to 30 degrees below normal plunged south, the temperature difference created perfect bomb cyclone conditions. If you live near large bodies of water and you hear forecasts mentioning significant air-sea temperature contrast or enhanced lake effect during a developing storm, that's a red flag for potential rapid intensification. Warning sign number 3, forecast model disagreement about storm intensity combined with a rapidly deepening upper-level trough. When the European model and American GFS model show different pressure forecasts for the same storm, and both are showing a sharply amplified jet stream pattern, that uncertainty often precedes rapid intensification. It means the atmosphere is in a state where small changes in initial conditions can produce dramatically different outcomes. During Winter Storm Ezra's development, Sunday morning model runs showed a spread of 8 to 12 millibars in predicted central pressure by Monday evening. That kind of uncertainty signals the storm is near a tipping point where it could either remain moderate or explode into a bomb cyclone. When you see forecast discussions acknowledging this uncertainty, prepare for the worst-case scenario. These warning signs matter because they give you a 12 to 18-hour head start on preparation, which could be the difference between minor inconvenience and life-threatening emergency. When meteorologists identify these signals in developing weather systems, That's your cue to accelerate your preparation timeline. Don't wait for blizzard warnings. Don't assume you have another day. Act immediately, because rapid intensification means the window for safe travel and preparation closes faster than traditional storms. Here's what you should have done Sunday morning, December 29th, if you understood these warning signs, and what you should do the next time this pattern sets up. First, cancel or postpone all non-essential travel immediately when pressure gradient tightening appears in forecast models. The travelers who left Sunday morning expecting routine winter conditions became the 9,000 delayed passengers and hundreds of thousands stranded on ice-covered highways. The travelers who canceled their plans Sunday morning based on early warning signs stayed home safely while the storm raged. Second, complete all emergency supply acquisition before the first precipitation begins. Once snow and ice start falling during a rapid intensification event, you won't have time to get to stores before conditions become dangerous. Stock a minimum 2-week supply of non-perishable food, water, medications, and heating fuel. During Winter Storm Ezra, people who waited until Sunday afternoon to shop found stores already running low on essentials and roads already becoming treacherous. Third, charge all electronic devices and fill bathtubs with water before the storm arrives. The 27,000 power outages that occurred during Winter Storm Ezra weren't evenly distributed. Some areas lost power for hours, others for days. When you don't know if you'll be in the fortunate group that keeps power or the unlucky group that loses it for an extended period, assume the worst. Charge phones, tablets, laptops, and portable battery banks to 100%. Fill every container with water, because when power fails, water pumping systems fail shortly after. Fourth, identify which room in your home you'll shelter in if you lose heat, and prepare that space in advance. Choose an interior room with minimal windows, preferably on an upper floor since heat rises. Move bedding, clothing, and emergency supplies into that space before the storm hits. If power fails during a bomb cyclone with temperatures in the single digits and wind chills below zero, you'll need a plan to survive without heat for potentially 24 to 72 hours while utility crews work in dangerous conditions to restore service. Fifth, establish communication protocols with family members before cell towers potentially fail. During widespread power outages, cell towers switch to battery backup that typically lasts 8 to 24 hours maximum. Text messages use less bandwidth than calls and are more likely to get through when networks are congested. Establish a communication tree where one person contacts two others, who each contact two others, creating redundancy in case some people can't be reached. Agree on a radio station everyone will monitor if cell service fails completely. The economic impact of Winter Storm Ezra's rapid intensification extends far beyond the immediate power outages and flight cancellations. The storm occurred during the peak holiday travel period, one of the most economically significant weeks of the year for airlines, hotels, restaurants, and retail businesses. When 9,000 flights get delayed and 889 get canceled, that's not just inconvenience for passengers. That's disrupted business meetings, canceled contracts, missed family gatherings, and billions in economic activity that simply doesn't happen. Hotels that expected sold-out weekend business faced mass cancellations as travelers couldn't reach their destinations. Retail stores that count on between-holiday shopping saw foot traffic collapse as roads became impassable. For businesses that depend on just-in-time delivery and tight logistics schedules, rapid storm intensification creates cascading disruptions that ripple through supply chains for weeks. Trucking companies that planned routes assuming normal winter driving conditions found their drivers stranded or forced to take lengthy detours, delaying shipments across the entire eastern half of the United States. Manufacturing facilities that expected Monday delivery of critical components faced production shutdowns when trucks couldn't navigate ice-covered highways. These aren't minor delays. These are major disruptions that affect inventory, production schedules, and ultimately prices consumers pay for goods. The insurance industry faces billions in claims from Winter Storm Ezra. Wind damage from 60-plus mile-per-hour gusts, power surge damage when electricity was restored, frozen pipe damage from homes that lost heat, vehicle damage from accidents on ice-covered roads, and business interruption claims from companies that couldn't operate during the storm. Each bomb cyclone event pushes insurance premiums higher for everyone as companies adjust their risk models to account for more frequent rapid intensification events. Here's something that almost nobody talks about but profoundly affects quality of life for millions. The psychological impact of rapid storm intensification creates a different kind of stress than traditional winter weather. When you have 48 hours notice before a major storm, you can mentally prepare, adjust plans without panic, and feel a sense of control over the situation. When a storm goes from routine to catastrophic in 12 hours, that control disappears. You make decisions under pressure with incomplete information, wondering if you should have left earlier or stayed home, if you have enough supplies or need to venture into dangerous conditions for one more store run. This uncertainty compounds with each successive rapid intensification event. People start to distrust forecasts, figuring if meteorologists couldn't predict how bad the last storm would get, why believe them about the next one? This creates a dangerous dynamic where people either overreact to every minor storm warning, exhausting their emergency resources needlessly, or underreact to genuine threats because they have become desensitized to warnings. Finding the balance requires understanding the specific warning signs I outlined earlier, recognizing when atmospheric conditions truly favor explosive development versus normal winter storm progression. For emergency managers and first responders, bomb cyclones create operational nightmares that strain resources to breaking point. When a storm intensifies rapidly, the window for pre-positioning equipment and personnel compresses dramatically. Snowplow drivers who thought they'd start their shifts Monday morning find themselves called in Sunday evening as conditions deteriorate faster than expected. Utility crews that planned to stage near predicted impact zones discover the impact zone expanded by 200 miles while they were in transit. Emergency medical services face simultaneous spikes in 911 calls for accidents, medical emergencies, and people stranded in vehicles, all while roads become too dangerous for ambulances to navigate safely. The 27,000 power outages winter storm Ezra caused don't just represent homes without electricity, they represent critical infrastructure failures. Traffic signals go dark, creating chaos at intersections. Water treatment plants switch to backup generators with limited fuel supplies. Hospitals activate emergency protocols, canceling elective procedures and preparing for generator-dependent operations. Cell towers drain their battery backups. Gas stations can't pump fuel. ATMs stop working. The cascading failures multiply the impact of the initial weather event far beyond what wind and snow alone would cause. Now let me address the question that's probably forming in your mind. If bomb cyclones have always existed and occur regularly every winter, why should this particular storm concern you more than past events? The answer lies in the convergence of changing atmospheric patterns and increasing societal vulnerability. Yes, explosively, intensifying cyclones have occurred throughout meteorological history, but they're now developing in locations and at times that maximize human impact rather than dissipating harmlessly over open ocean. Our infrastructure, designed for climate normals that no longer apply, buckles under conditions that are becoming the new normal rather than rare extremes. The electrical grid in the upper Midwest was designed assuming a certain frequency and intensity of winter storms based on 20th century climate data. When storms intensify more rapidly and produce stronger winds than historical precedent, power lines fail at higher rates than the system was designed to handle. The airline industry optimizes schedules and aircraft positioning based on typical winter weather disruption patterns. When rapid intensification produces unexpected blizzards, the entire system crashes harder than historical models predicted. We built our society around climate stability that no longer exists, and each bomb cyclone reveals how poorly adapted we are to the new reality. Looking ahead to the rest of winter 2026 and beyond, atmospheric conditions favor continued bomb cyclone development. The stratospheric sudden warming event that occurred in mid-January has destabilized the polar vortex, allowing Arctic air to plunge south more frequently and more deeply than normal. When this Arctic air collides with warm ocean currents or warm Great Lakes waters, the temperature contrasts necessary for explosive cyclogenesis occur more readily. Climate models project this pattern of Arctic amplification and increased waviness in the jet stream will continue and potentially intensify, meaning rapid intensification events may become more frequent. This doesn't mean every winter storm will become a bomb cyclone. It means the percentage of storms that undergo rapid intensification is increasing, and the geographic range where this can occur is expanding. Areas that historically experience bomb cyclones only over open ocean may see them develop closer to shore or even inland over the Great Lakes, as Winter Storm Ezra demonstrated. Communities that never needed to prepare for rapid intensification events now need those preparations as part of routine winter readiness. The responsibility for adaptation falls on multiple stakeholders. Utility companies need to invest billions in grid hardening, burying power lines, and increasing system resilience to handle winds and ice loads beyond historical design criteria. State and local governments need to expand their winter storm response capabilities, purchasing additional equipment and training personnel for rapid deployment when storms intensify faster than traditional timelines. The federal government needs to update building codes and infrastructure standards to reflect changing climate baselines rather than historical normals that no longer apply. But individual responsibility matters most because government and corporate adaptation lag years behind atmospheric changes that are happening right now. You can't wait for utility companies to bury power lines or for building codes to mandate stronger construction. You need to prepare your household today for the reality that winter storms can go from normal to catastrophic in 12 hours. And when that happens, you're on your own until emergency services can reach you, which may be days rather than hours. The checklist is straightforward but requires commitment and investment. 2 weeks of food and water that doesn't require cooking or refrigeration. Backup heating that doesn't depend on electricity or natural gas. Multiple layers of warm clothing and sleeping bags rated for temperatures 20 degrees below the coldest temperature in your area's historical record. Battery-powered or hand-crank radio for information when internet and cell service fail. First aid supplies including prescription medications for any chronic conditions. Cash money because electronic payments stop working during extended outages. And most critically, the mental preparation to make hard decisions quickly when conditions deteriorate faster than forecasts predicted. Winter Storm Ezra will not be the last bomb cyclone to catch millions of Americans off guard. The atmospheric ingredients that produced its rapid intensification remain present and may become more common as climate patterns continue shifting. The difference between being a victim and being prepared comes down to understanding the warning signs, taking them seriously even when official warnings haven't yet been issued, and acting decisively before the window for safe preparation slams shut. 12 hours separated routine winter storm from catastrophic bomb cyclone during Winter Storm Ezra. Will you recognize those 12 hours when the next rapid intensification event begins developing? Your answer to that question may determine whether you experience minor inconvenience or life-threatening emergency during the next explosive cyclogenesis event that meteorologists are certain will occur. They just don't know exactly when or where yet.